Thank you again for joining us at the 2020 Sloan Sports Analytics Conference Competitive Advantage Talks, brought to you by Kraft Analytics Group. My name is Matt Kilby, and I'm a first-year MBA student at MIT Sloan, and it is my pleasure to bring to you our presentation, How Cricket Innovates at 100 Miles Per Hour, brought to you by OutSystems. When you're asking questions following the Competitive Advantage talk, please wait until you get the microphone to ask your question. Please join me in welcoming our speaker, Damian Smith, Head of IT, England and Wales Cricket Board, to the stage.
Thanks very much. Welcome, everyone. I'm Damian Smith, Head of Information Technology at the England and Wales Cricket Board. I'm going to talk to you today a bit about how we're solving a couple of problems. I'm going to define my terms, how we're solving what I'm going to call the analytics problem, and the other thing that we're solving is the IT problem, and that is how we go about delivering performance analytics and all technology to the world of cricket. We use 4 key technologies that I'm going to talk about. We're using cloud, big data, low-code apps, and artificial intelligence and machine learning. And we knit all of those things together to deliver incredibly quickly. So, are there any cricket fans in, so I can gauge my audience? There are some. That's more than I thought, right? And are there any cricket phobes or people who just don't know what cricket is or just don't? Okay, I'll pitch appropriately then. Okay, so the England and Wales Cricket Board is the national governing body for cricket. So I guess it's a bit like Major League Baseball, NFL, those kind of things. We have about 10 million fans in the UK. And of those 10 million fans, about 2.5 million of those will play a game of cricket during the year. And of those 10 million fans, about 1 million of them will attend a professional game of cricket. My team looks after 4 key pillars of the game. We look after all recreational cricket. So that's your quintessentially English game of cricket on a village green with white picket fences and pubs and warm beer. And those people playing those games will have scored their game or be scoring their game on their phones or on their tablets. The umpires, the coaches, the scorers will all have qualified using our learning management systems. They'll be members of our membership systems on our professional scoring, our professional membership systems. And all of the technology that looks after that game. They'll also increasingly now be analysing and videoing those games of cricket and sharing them on social media and sharing them with their friends and colleagues. Professional cricket is more about the venue experience, so it's about high-density spectator Wi-Fi. It's about all of the things behind the scenes, so the scoring, the analytics, video analysis, that kind of thing, the tech that puts on the game, and then I guess also in keeping with the other things, the other sports, it's all about the venue presentation, so scoreboards and integrating that technology together and all of the kind of LEDs, as well as ticketing, media accreditation, all of those kind of things. Then elite cricket, this is the sexy sports science and medicine bit, the bit that we're all here for really. So this is all of our statistical analysis, our video analysis, it's our biomechanical analysis, biometric analysis, anything you can put analysis in front of, as well as medical imaging and all of the things that we need to do in order to get fitter, better athletes winning more matches and having fewer injuries. And then the 4th kind of pillar of the game that my team look after is all around governance. So that's safeguarding of children and then also onto the anti-corruption, anti-doping, financial governance. So all of the case management systems, the analytical systems, everything that looks after those aspects of the game. So there's a lot to think about. It doesn't feel like a proper job. There's an awful lot to do. And I guess trying to prioritize where we focus our efforts is one of our major challenges. So I've been using an analogy for a number of years at the England Welsh Cricket Board, which was a really good analogy a few years ago, but it hasn't aged particularly well, because I always say that we have the same business model as Facebook, but now Facebook are evil, right? So it's, people are less comfortable with it. But I think it still holds true, so bear with me. What I mean by that is there's a truism in IT, which is that if you're not paying for something, then you're not the customer, you're the product. So I, as an individual, I might use Facebook, but I'm not paying for it, so I'm not their customer, I'm the product that they're selling to advertisers. And the more of me there are, and the more they know about me at an excruciating level of detail, the more money and investment they can get from advertising. Now, national governing bodies are exactly the same, except our product is our participant. So the more people we have playing, attending, following the game, the more investment we can attract from broadcasters, sponsors, and government to invest in the game, and that's primarily where our funding comes from. So, for example, last year the UK hosted the Cricket World Cup and won the Cricket World Cup. And if 10 people had watched Cricket World Cup last year, then our media rights would have been worth about $10. As it was, 1.6 billion people globally watched the Cricket World Cup. So that has a massive impact on the value of our broadcast and media rights, and also the attractiveness of people who want to sponsor us for their reach for their sponsorship brands. So I said we're going to talk about two major problems that everybody has, and I'm not talking about just sports organisations, I'm talking about all organisations. The first one I'm going to call the analytics problem. So the analytics problem I describe as somebody has a requirement for some kind of analytics, some kind of dashboard, something like that. So they tend to come to the IT department and they say, right, I want a dashboard that looks like this. And then if you're lucky, then the IT department might have a data warehouse. And what they'll tend to do is they'll go into the data warehouse and they'll say, right, have we got all the data that we need to satisfy this reporting requirement, this dashboard requirement? And the answer, more often than not, is no. So you'll have to go and look for additional sources of information. So you go and look for additional sources of information. You might find an appropriate source of information to help satisfy this report. But then you have to do some source systems analysis. You need to understand what that data is, how it's structured. You might need to understand its data quality. You might need to do some data profiling. And then if you find that it's of poor quality or it's just structured in different ways, you might need to do some data cleansing. And then once you've done your data cleansing, then you'll need to build some extract and transform and load processes to get it into your data warehouse. And then your data warehouse will need to change to accommodate this new data. And then your reporting layer will need to change, your semantic layer will need to change in order to build these new reports. And then you'll build your new report, and then 6 to 9 months later, you'll turn around to the person who asked for this dashboard and say, is that what you wanted? And by that time, they've moved on. They're all like you guys. They're growth mindset, highly motivated people who are leaving no stone unturned to try and get better, fitter athletes. So they've moved on to the next thing. You're just not responsive enough for them. So we solve this using, I guess, two key components. So we've got a similar setup. We've got all of our data sources. But what we do is we lift and drop them straight into a data lake. So there's none of this source systems analysis, none of this data profiling, cleansing, anything like that. We drop them into a data lake. This is deliberately on Google Cloud Platform. It could equally be on AWS or Azure or Alibaba. There's no reason, but it needs to be cloud because it gives you that responsiveness. It means that you can just pick it up and drop it in there, and then it's immediately available for producing analytics. And then the other thing that we do is we build a lot of apps in low code. So we use OutSystems as our low code application development environment. Other low code platforms are available. But this is because we have a number of learnings from building data lakes. So when we built our data lake, we thought we would be building lots and lots and lots of reports, analytics, BI reports, that kind of thing. And we found a really interesting phenomenon, which is that unless you're an accountant or an insight specialist, you hate using BI tools. BI tools don't do what you want to do. You get confused easily by them, and also once you've found your bit of insight, the next thing that you need to do is outside of that BI tool. So we build a lot of apps. We build them in preference to dashboards, although we do still have analytics people and accountants, so we are still building dashboards. But if we get maximum adoption, the way to get maximum adoption for our things is to put them on the tools that people are using. And players very rarely fire up a laptop and look at a BI tool. They're on their phones all the time. And coaches are on their tablets all the time. So we put it on the medium that's going to reach them. And then the one luxury we have in sport is that we can make every query end with a video, because that thought process of all of these practitioners is to say, right, show me the data, I understand the data, I understand the analysis, now show me it in real life. Now, I've been building these things in industry for years and years, and you can't do that in investment banking. You can't end with a video. It's not very interesting. But in sport, there's always a video to put at the end of it. So I said I'd define two things. The second problem that we're solving is the IT problem. I'm not sure if everybody still talks about the waterfall approach, but when I did my first degree in computer science, we were taught the waterfall approach 30 years ago. Basically, if I describe how IT worked a number of years ago at the England and Wales Cricket Board, we'd have our sports science and medicine department would come to the IT function and say, right, I've got an idea. I need a system that does X, Y, Z. I need a new computer system that does this thing. And IT, in true corporate fashion, would say, thank God you're here, fill out this business case in triplicate, and we'll put it to our IT steering group, which meets every 6 months. And immediately, you've lost all of that momentum. And then, it does go to the IT steering group. If you are lucky enough to get the white smoke coming out of the IT steering group that says, yep, you've got the go-ahead to go with your project, and you've no idea how to influence this mysterious group. If you're lucky enough to have that group approve your project, then in comes IT. We engage, we descend, we do a big requirements gathering exercise. And because you don't trust that you're going to get another shot at this, you don't think that you're ever going to get another chance at getting funding for an IT project from this mysterious board, you throw every single requirement you can think of under the sun into this project. And the scope gets massive. And then IT, because we see this massive, complicated scope, we think, right, what are we going to do about this? We need to manage risk. We're going to have to buy a package solution that does this. But of course, you're at the bleeding edge of your field. So there is no package solution that does this. So we have to compromise. We either buy something that does 50% of what you want to do, or we buy something that does what you want it to do, but in a different industry, and we kind of have to abuse that functionality and crowbar it into what it is that you're doing. And then what we do is we build that. It takes us so long to do the requirements, so long to do the design, so long to do development, and then 18 months later to 2 years, we roll out the system going, is that what you wanted? And of course, the world's moved on then, you've lost patience with the whole process of engaging IT. That's the waterfall approach. How do we solve this? At the ECB, we solve this using an innovation lifecycle. So instead of building big systems, we funnel all of the ideas that you might have. And then we say, right, what's the next idea off the rank? And we say, how can we prove in a very short space of time whether this is going to be a good idea? So we build something, hopefully in about a week. So in this example, it would be building an app, but it might not necessarily be a technical thing, but any kind of innovation, how can we put some parameters around it to prove whether or not this is a good idea or a bad idea? And we very rarely, after that week, have a bad idea. We don't sort of say, here's a bad idea, we'll never talk of it again, and then just get rid of it. We tend to park it because we all know there's no such thing as a bad idea, is there? It's usually because the technology isn't up to it or the organization's not up to it. So we have examples of this. We've been trying machine learning for video analysis for a number of years now, and it hasn't really worked, hasn't been up to it. The models haven't been sophisticated enough, granularity hasn't been good enough. But actually now, last 12, 18 months, we've made massive strides. So we've been able to revisit it every time there's an improvement in the technology. If after a week you've proved that it's a good idea, then you can very quickly scale it. So if it's an app, we can put it on the App Store, or we can push it to everybody's devices as if it's for internal consumption. We can very quickly scale it. So from a minimum viable product and then iteratively grow it. So I've got a couple of case studies for this. The first one is about fast bowler biomechanics. I've got a very short video. It's important to note that this video was made a few years ago, and while it's nice and says these are all the wonderful things that we do at the National Cricket Performance Centre, there are also a couple of issues with it, which I'll talk about afterwards.
We're at the National Cricket Performance Centre at Loughborough, and we're doing our annual Vicon testing, which is the gold star analysis sequence that we do with all of our up-and-coming young fast bowlers through the pathway, and also England Lions pace programme.
The collections today are based on young players that we believe may have a future in an England pathway, and trying to get them at an early stage and then track their development through.
From a coaching perspective, we're trying to make them bowl faster, or help them to bowl faster, and to have more craft.
With trying to provide player-specific coaching programs from the research we do, then it will take them certain players that get access to it to the next level. We use a motion analysis system. It's a system which enables us to track 3D markers.
It's allowed us to look at what fast bowlers look like. And one thing we have found is that there is a shape, but it's very individual. And now we're using that technology to build a model which allows us to put the individual on it and find out what they're capable of. Now that's really exciting, because if you think of coaching, we look at someone, sort of make an assessment, and then we try and work out where they can get to. And that's great, and through experience we're getting better at that, but there's nothing more effective than saying this is what they're capable of based on facts.
You give myself some feedback on how my body's working when I'm bowling, where it works best and things like that. So I'm looking forward to seeing how it comes out.
We're looking at lots of different things, so how hard they hit the floor, which is quite important when you're bowling them for an awful lot of overs. We look at their actions to make sure they're safe.
We can screen to look at predictors of stress fractures. So some research has shown that a counter movement can be the lead to it. Some research has shown that a large amount of side flexion with a large force.
But we're also looking for the pace indicators. You know, have they got those characteristics of fast bowlers, and can we see them develop?
We have some characteristics we look for, so a faster run up, a straight front leg, ball release, a large amount of trunk flexion, and a delayed bowling arm. And so we screen our players now looking for these characteristics.
This type of training is definitely beneficial, because obviously you get feedback from it, and then go from there. You can tweak the slightest things to help you improve.
That's the beauty of all this technology. It gives us a good picture of where the bowler's at, and then can we work out a development program to get them better and better and better.
So that was the head of fast bowling, former head of fast bowling, Kevin Shine, or Shiny. I don't know if this happens in the States, but everybody's got a nickname. So that was Shiny and Feltsy. And they had a couple of challenges. The main problem here that you saw was that this is the annual Vicon testing. So we get the players once, if we're lucky, twice a year. They get all enthused about what they're capable of, all of this technology. And then what happens is they go back to their clubs, they go back to their teams, and they lose touch with our National Cricket Performance Centre. And worse than that, we get this difficult ongoing dialogue because they're not now within our kind of control, or they're not near us, within our proximity to talk with us. And there's also an element of what we do at the National Cricket Performance Centre is seen as a bit lofty, a bit remote, rocket science in this kind of ivory tower of the National Cricket Performance Centre. So Shiny's idea, so Shiny came to me and said, Damo, because of course that's my nickname, Damo, I've got an idea, can we put all of this in an app that we can share with players and coaches and do this year round so that we have this ongoing dialogue with people. We can then create development plans with them. We can then share all of the insight that we know on these occasions, and we can also just plan and improve these bowlers. And then I guess we can get increasing engagement and understanding of what it is that we're doing with the leading edge research that we do. So we did. After a week, we were able to produce this app. This is the first minimum viable product that we produced. It looks a lot different to this now, and I'm happy to show people over the next couple of days if you want to come and find me what it looks like now. But basically, list of all of the fast bowlers on the PACE program, and then I can click into one. So here's Tom Helm. I can get some high-level details about what he's doing, and I can drill into individual performances. But crucially, there's this dashboard which has a number of KPIs about things that they were looking for. So you heard Feltsy talking there about chunk flexion and things like that, and you heard Shiny talking about pace. And then we've got different models which, if you go into them, then what we're looking at here is a machine learning generated model of somebody with Tom Helm's physique and what it optimally looks like, taking into account all of the musculature and the biomechanics of the skeleton, to bowl injury-free and at maximum pace. So there's a couple of things you heard Feltsy talk about here. This is where I pretend to be a biomechanist, but on the front leg that is delivering, apparently it needs to be straight. I think it looks horrific. It's almost kind of hyperextending, but apparently that's very good because that means that all of the pace generated in the run-up goes into the ball that's delivered. It also means that all of the strain goes through the bone and not the soft tissue, so you're less prone to those kind of injuries. So then we can look at how Tom Helm does. So this is him, and we can say, right, what's his front leg doing? Is it straight? It's okay, it's not kind of hyperextending, so, I don't know. That's where the art meets the science, because then that's where the fast bowling coaches work out how to make these tiny tweaks so that they don't ruin the action and then get them forgetting everything, but just change bit by bit what they're doing. So the other thing that this platform can do is enable people to share video. So on here, we've got Kitty Stewart, who is a performance analyst, has uploaded a number of videos that show Tom Helm bowling at his best, or how they want him to in practice. So he's always got those as reference things. And then I guess the players can then upload their own video, and the coaches can from their net sessions, from their practice sessions, and then say, what do you think of this? He started falling over, or he started moving like this. Is that okay? And then they've got this all year round engagement with us. So the project builds better athletes. One of the people that you saw in that clip from a few years ago was Sam Curran, who's now a regular in the England team. And we have this nice kind of pathway coming through of players that are playing. We have fewer injuries. We have lower costs, not only because of the fewer injuries, but also because of the time taken to market for a piece of IT. We get it in really quickly. It doesn't cost us that much money. And then we have better engagement with the research. I think I've got just enough time to do one more case study. A couple of observations there. Everybody wants an app after that. So people, head of spin bowling wants an app, but then you have to say, right, well, why? And well, I don't know, I just want an app and it looks nice. We have to be ruthless about the justification for it. Adherence to the process is everything. Sometimes we go for a week and we say, well, it's nearly proving what we want. Let's run it for another week. And then let's run it for another week. After 3 weeks, 4 weeks, we go, no, we've got to kill it, park it for a bit. There's plenty of other ideas to work on, so we'll do those. And then it's very easy to do with a room full of people like you who are growth mindset, incredibly keen to leave no stone unturned. Other parts of our organisation generously are a bit like the civil service and want to engage with IT in traditional ways. But we now have this growing portfolio of delivery to say this is the best way to deliver IT projects. One quick last piece that I'll cover, I've got about a minute left. There's a challenge in every sport, which is that getting players from professional game to an international standard, not everybody makes it. And there's lots of hypotheses for why this may be. It might be psychological, it might be to do with the stress and the environment and things like that, but there are other contributing factors, which it may be that you're just very good at professional cricket, but not good at international cricket because you're achieving all of your batting runs or your bowling wickets against pretty mediocre opposition. So if we could somehow weed out all of the non-international quality deliveries and look at your stats based on international quality delivery, then we would have a really good idea of how good you are and whether or not you're going to make it. So what you're looking at here is a mobile system that uses a couple of devices. It's a bit dark in here, but basically there are two umpire positions on a game of cricket. There's one viewed from here with a device on this particular umpire, and then there's another one who stands behind the stumps. This is the same delivery. And then what's happening here is they've both got a device which is capturing the ball, and then in the spirit of that diagram I showed you, that goes straight up into the data lake. We use some clever artificial intelligence tools which then track what would have happened to that ball and then send it back down to the device. And I'm not sure if you can see here, what that's saying is that it tells you exactly where the ball pitched or bounced. It tells you exactly how fast it went at 77.9 miles an hour. It tells you how much it moved in the air, and it tells you how much it moved off the ground. And all that's happening there is that information is going up to the cloud and then coming back down to a low-code app. This has been built using all of the technology that we've said so far, but the crucial thing is that the device on those umpires is a mobile phone. So we built this for professional cricket, and actually everybody's got a mobile phone. So we might just have built something incredible for the recreational game, because now I can do this on a beach, I can do this in a car park, on a patch of land, and I've got this kind of high-level analytics. So what this means is we've proved all the technology here in this innovation life cycle. We've now got to work out all of the other subtle things about that, like, are the umpires holding the stuff in the right place? Have we got batteries that last long enough for a game of cricket? Have we got coverage to send this stuff up to the cloud? But they're all surmountable problems, so we will get there. And it's all part of this innovation life cycle. And crucially, the lesson that we've learned is that when you start off with one of these ideas, you don't always know where you'll end up. So we've started off here thinking we're going to solve something for professional cricket. We now find that we might have something incredible for grassroots cricket. And we have this nice trickle feed from the elite game through to the recreational game all the time. And what this has led to is the Amazonification, I call it, of the ECB. I probably ought to call it the Googleification. There's kind of things about Googlies in cricket, and also we do it all on Google Cloud Platform. But what I mean is we're becoming more evidence-based, more data-driven, and we're getting more used to failing and scaling in everything that we do. I was going to give you a couple of examples, but I've run out of time. I'm happy to talk about these things afterwards, but I've got a couple of examples where that's happening not in technology, but just the rest of the organisation, in the way that we engage children and in the way that we create new formats of the game to engage new people. But otherwise, I'm very happy to talk about any or all of the aspects of cricket at any stage. I'm here for the next couple of days. Very happy to talk to all of you, but thank you for your attention. Do we have time for a couple of questions? One or two, I think. Yeah? Sure. Absolutely, yes. So the question was, do we do any analysis on the pitch type? Yes, we do. So all of that technology tells us the speed at which the ball hit the pitch, tells us the speed at which it left the pitch, all things like grass type, how many times you have to roll the pitch to get different kinds of surfaces to play on, and all of those things, because that's the big unknown in a cricket pitch, in a cricket match, is the quality of that pitch. Yeah.
Hey, about halfway through the presentation, you talked about some computer vision advances you guys made in the past 12 to 18 months.
Yeah.
Could you go into a little bit more detail about what
Yeah,
these
certainly.
things were?
So what we do is we take an entire day's play, which we then slice up into individual deliveries. Now, we used to have a human doing that, and we still do have a human doing that. Very often they would be a sports science and medicine undergraduate who wanted to get into Premier League football, tried to and failed, tried to get into Premiership rugby, failed, and now they find themselves at a 4-day rain-affected match in Derby after lunch, kind of falling asleep and then thinking just what happened. So now what we've done is repurpose some Google DeepMind models, which we kind of test for a number of different things, which if those things happen, then we can say a delivery started a number of seconds earlier, and that's more accurate now than a human can code it. So the next things are, we can then tell just from video, without using kind of triangulation, we can tell from video where the ball pitched, what shot was played, and all of those kind of things. And the aim is to, if you like, there's a vast amount of unstructured data in video, is to extract lots and lots of metadata from it in order to be able to do some analysis. Okay, thanks very much. Cheers.